Hi, everyone. Thank you for joining in this awesome conference, Devoxx, which is really the experience so far for me is awesome. And this talk will be about Terraform practices to enable infrastructure scaling. And Terraform is a great tool, right? It is used widely across the world. And this this talk will cover not only specific bits and pieces regarding Terraform usage and practices, but also will help you hopefully think about Terraform in a broader context rather than just an infrastructure as code tool. So you'll be able to scale up your infrastructure and the teams that uses Terraform. So first of all, and very quickly, hi, my name is Hila. I'm a senior DevOps engineer and I work for Wix, which for those of you who don't know, we provide platform for building websites either for tech-savvy people or not. I have 15 years of experience in the tech industry. DevOps culture fan. I'm involved in a lot of communities, so I'm in the AWS Community Builders Program, and I'm also an HashiCorp ambassador. I am a co-organizer of conferences in Israel, where I live, DevOps Days Tel Aviv. I'm a mentor in courses and communities, and in my spare time, I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so Terraform implementations could be good, bad, and sometimes also ugly. Small disclaimers. First of all, I'm going to show mostly examples from AWS, but Terraform works with all cloud providers out there. And I'm going to talk about Terraform, the open source one, and not the cloud or enterprise, and I don't even use them. So probably the implementations for cloud and enterprise will be different. So just bear that in mind. This is about Terraform open source. Okay, first of all, quick wins. So these sections will be about low effort, high value things that will help you scale better and more efficiently and prevent refactoring and extra work later on. So first of all, versions lock. What are versions in Terraform? Same as you have for Python requirements txt, where you can lock the versions there, or for package lock JSON. It's the same thing. You can lock versions for Terraform modules, providers, and Terraform version itself. This is how you do it, examples for each one. And this is good because what is a version? It's a set of features and expected syntax. So it's good to lock them because then you know exactly which syntax is expected, which features. And another thing is that this is a meme by Anton Babenko. If you don't know him, he's like a Terraform celeb. And from this meme, you can see that sometimes providers have issues, and it's better to deal with the devil that we know. So lock the versions, and then you'll deal with the devil that you know, instead of dealing with the unknown, which could be very frustrating. So the good thing is to lock your modules, providers, and Terraform versions. The bad thing is to lock in a way that will still allow breaking changes to your core if you, for example, lock to a minor version and not a major one. And the ugly thing is to have no versions lock whatsoever. You will have conflicts and breaking changes, and it wouldn't help your teams in the long run. So always try to lock versions as much as possible. The second thing in the quick win section is to tag your resources. So for me, it is a must implement practice because it allows us to filter the cloud provider expenses and sort them by tags to distinguish between resources. It also allows you to do cost control in some tools like Datadog, for example. And it will help you to gain visibility on ownership and overall projects by tagging according to a logical breakdown. And also, another reason why to tag resources is because if you do that, then your FinOps team will be happy. And if you don't have a FinOps team, congratulations, you are the FinOps team. Okay? So just have that in mind. And on the left, you see some tags that we use in Wix that helps us for our tagging resources. And on the right, you see the in AWS, the provider AWS has a feature of default tags, which means that if you set up the tags in the default tags, all resources will inherit those tags from the provider, and you don't need to think about it. All resources will automatically get those tags. So the classic usage is for managed by Terraform, but you can set up anything that comes to mind, like provider AWS or anything that you want. So the good thing is to tag everything that you can, use default tags as much as possible, and you can set up PR enforcements to fail a PR merge if no tags were added, and I will cover practices enforcement later on. The bad thing is to tag inconsistently because, as we know, consistency is key, and it will be very hard to track things if it's not consistent. And the ugly thing is to have no tags whatsoever because, again, no tracking costs, no tracking to understand which resources belong to which teams, so it is very problematic. And the last section in the quick wins section is a remote state. So by default, Terraform works with a local state, and remote state helps scale your team because everything is remote and you have one source of truth. So this is how you define it in AWS. You can set up the backend as an S3 bucket that will keep the state file there. The good thing is to have your state file remote and secured. You can and should have the state backed up. You can use S3 versioning for that, for example. And you can set up state lock. So whenever you run Terraform apply, you can set up a state lock in a DynamoDB, for example, or you can do it through other tools like Atlantis, which I will cover later on as well. The bad and the ugly is pretty much the opposite. So using local state is not remote. The state is remote but not backed up or secured, and the state is not really locked while you run Terraform apply. Okay, these were quick wins, right? Things that you do and you can achieve in a matter of minutes in order to get the most out of Terraform to enable you to scale. Now I want to cover second nature. Second nature are basically day-to-day awareness that will help you reduce refactoring code in the long run and prevent time waste and basically align to best practices, either Terraform best practices or even best practices that you will set up as a company or as a department. So let's see. First of all, using community models versus creating the models yourselves. So there's a saying, right? Do not reinvent the wheel. And a lot of well-known cloud providers' features are already covered by models, so just use them. And why? Another reason to use them is because they are proven over time. They are supported by the community, and you don't need to support them and maintain them yourselves because there are other people in the community that do the support for you. For example, Anton Babenko that I mentioned before, he supports and maintains most or all of the Terraform AWS modules, which are a lot. So that's basically it. And another thing why to use community models is that they have the practice enforcement that I'm going to cover in a bit, which means that they check that the code that gets introduced to the models are in a high quality, and it allows new users to get easily involved and contribute to this model and use it while preserving a high quality of a code. So this is all of the reasons why to use community models. So use community models and verified ones as much as possible. When I say verified, up until I don't know how much time, but in the Terraform registry, you had a verified label for the community models that are verified, but HashiCorp removed that. So the way for you to know that the models are reliable is to check out the number of downloads. If there are a lot of downloads, probably they are safe to use. So use them as much as possible. Of course, if it doesn't fit the use case, you can't use that, and that makes sense. The bad thing is to create custom models, but still maintain them as a community model, which means to have practice enforcement and to apply classic code best practices, which I also gonna cover in a bit. So if you still do that, that's okay. Another bad thing is to have community models without versions lock, as I mentioned before, for the same reasons from before. And the ugly thing is to both create a custom model and not maintain it, because then it will get out of hand. It will be very hard to maintain it when it's not really maintained day to day. And if you use unverified community models, then you potentially could introduce malicious configuration into your environment, so you should avoid that. And if you do have to create your own models, then make sure you try to make them as stateless and clean as possible. Do not repeat yourself, keep them as generic as possible, and you introduce enforcements to maintain the quality of the code. I know that I mentioned the practice enforcement quite several times, but and it's like a build-up until to that section, but trust me, it's worth it, so bear with me. And yeah, that's it. Okay, next section that I want to cover here are variables versus locals. So unlike variable values. Local values can use dynamic expressions and resource arguments. And locals also don't change values between or during Terraform runs, so that's why they are called locals. And you can use locals to give a name to a result of any Terraform expression and reuse that name throughout your configuration. So this is an example. For tags, for example, you can set up variables for project and environment, and then require tags are something else, and then you can merge with locals. You can merge the require tags with other variables, and then have a final definition of tags that will get reused throughout this module. So on the module side, for variables, it is intended to be settings for the module configuration, but you should make sure you set up default or validation for that variables, because if not, the module will get break if it's not passed, the values weren't passed. And for locals on the module side, you should consider it as a constant to be honored or relied on. So if, for example, I have S3 bucket module creation, then I can set up the naming convention for that, for all the buckets that will get created through that module, and then everyone is bound to that naming convention, which is good because we all want to know which bucket belongs to which company and which department, for example. In this specific example, just bear in mind that each cloud providers have their own limitations of characters limits and stuff like that, so if you do have some settings for that, just have that in mind. On the live side, and when I say live, I mean where we call the modules, because modules is like a class in code, and then live is where you do the instantiation of the class. So on the live side, where you call the modules, if you use variables once, just set a default, and if you use it per region, etc., use tfvars that helps you reuse the variables. For locals, you should try to avoid using locals as much as possible because we want to leave the logic to the module side. So if you don't have to use locals, don't do it on the live side. And you should utilize data sources to pass outputs to the module because it is a dynamic way to get the most up-to-date infrastructure and configuration. So it is a good way to use it in the live side. So the good thing about variables and locals is you should use tfvars whenever necessary. Utilize environment variables if there are such, because then you avoid the need to create more variables to compensate. Use locals to hard code one-time names and decrease code repeatability, and try to keep things generic as much as possible. Bad things in regards to variables and locals is that Terraform allows you to create multiple blocks of locals, and it could be hard if you don't centralize them as the same as you could decentralize vars. So just make them centralized, one variable files that includes both local and variables, and that's it, because then it will be easier to maintain, and ignoring environment variables because then you need to create more variables to maintain. The ugly thing is basically pretty straightforward. Hard coding variables whenever it's not necessary, because this is variables, right? They need to vary. So don't hard code stuff if you don't really need to. Next section, file structure. I don't have time. Okay, so file structure is, we can take example from the community module. This is how they structure the files, main, variable, data, versions, and I can do also other things, like if I have a module that creates a VM, I should keep the peripheral stuff like load balancer and security groups in other files, and keep only the main logic in the main TF. And in terms of sub and nested modules, if you created a complex module, for example, you should break it down to sub-modules, and that way you both able to reuse that modules independently, and also you don't need to maintain gigantic variable files because it is separated throughout modules. Example from the community for that, the VPC module has a sub-module of VPC endpoints, and the EKS module have a sub-module of a node pool creation. Okay, this is a fun part that I really like to get to in this presentation, applying classic code best practices on Terraform. So I know that this is a room full of developers. I'm not saying that Terraform is a pure programming language, okay? Don't worry, I'm not saying that. But similar rules of writing code apply to Terraform as well. How do I know that? Because Terraform progressed over the years in a way that adapts classic code best practices. Before Terraform 0.13, you couldn't even loop over modules, and from this version on, Terraform finally introduced the ability to loop over modules with a single module call. So even HashiCorp realized then that we should apply code best practices on Terraform, and this is something that you should do, which means keep the code in source control management, keep it as simple as possible, do not repeat yourself if you don't have to. Even principles of functional programming can be applied on Terraform. The code should also be idempotent, of course. And in terms of human and clean, I want to quote something by Thyssen Uo, great article that I have a reference to it at the end. He says that the computer that processes your code doesn't care if the variable names are ambiguous or inaccurate. If it used correctly, it will just get executed. But since human beings are the ones to maintain code, we need to have clean code and naming conventions and all of these things for the sake of us human beings and not for the computers. So that's why applying code best practices is very important also in terms of Terraform. Okay, the last section that I want to cover here is the long haul. Long haul is basically like the long run kind of thinking that you need to have with Terraform. And why is that? Because teams need to do work on the same infrastructure, or they need to have visibility, and we need audits, and we need to isolate environments and track their changes and their effects. So to handle all of these, we should consider these long haul practices. But before I get to this section, I want to ask you this important question. How do you envision the infrastructure and the company's needs? Because we really need to think things through and do what's best for the company's needs and infrastructure use cases. I usually have a story that I tell here, but I'm not sure I'm going to have time for the entire story, so maybe I'll tell it at the end. But basically, don't use Terraform just because everyone uses it. Don't use Kubernetes just because everyone else is using it. Think about your use cases and your really the application use cases and the infrastructure one, and then see what is best. What is the best solution to choose for to answer these needs? So, since we planned ahead, we thought about our needs. We understood that Terraform is the way to go, and we decided to structure the code base in a way that will make sense to us, and I really hope that it will make sense to you, because there are a lot of ways to structure the code base. So this is how we do it. We start out with a team, project, cloud provider, and region. Everything is in the same repository, by the way, which is very important to mention. This is how it gets manifested. So we have live and modules, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. Why did we choose to do this structure? Two main reasons. First of all, to have Terraform as a platform. That way, first of all, we can onboard all teams to use the same code repository, and they can benefit from the modules in that repository, and they can benefit from the practice enforcement, the checks that we have to make sure that the code is in a high quality state, to check that tags are added, and all of these things. So they get out of the box models that everyone else is using. And basically, that's the main reason. And really, once we did that, all teams that need to use Terraform just add their own folder. We utilize code owners in GitHub, so they can approve their own PRs. So it is awesome. So this is a main reason why we do that. Another reason is to handle state files, because if you structure the code base in a way that will have huge state files, then it will cause a lot of issues with Terraform. Why? Because sometimes Terraform creates invalid dependencies, and we want to prevent that. And we need to help Terraform do its job sometimes. So in order to help Terraform, we need to have small state files as much as possible, because again, we want to prevent big blast radius. So in this example, the state file is kept in the US East 1 level, which means the state file only holds resources for Airflow in the BI team in the US East 1 region, which is very, very small. So that's why we eliminate big blast radius, minimize invalid dependencies, win-win for everything and for everyone, and I don't run a change of tag and then the plan shows me destroy of resource, okay? This is what happens when you have huge state files. Workspaces. Do I have time to work on workspaces? Yes, I have time. Okay. Workspaces in open source Terraform basically means to isolate states between between workspaces when it makes sense, when we have the same Terraform config for different customers, for example. So that way, all customers have the same, and we use the same code for all customers, but each customer has its own state file. Coupled with that, let's say all customers need to use the same multi-tenant, which is the same service like login service or financial service. So in that case, these services will also be kept in, or could be kept in workspaces as well. Some notes about workspaces though. First of all, you should really consider using a Terraform wrapper when you work with workspaces. And why is that? Because how do you work with them? With the CLI, Terraform workspace select X. If I forget to do this select, production incident, okay? And it happened. So try to and really consider using Terraform wrapper, and that way you're not the one to handle the switches between the workspaces. A code will do it for you, and then you prevent human errors. Another thing about workspaces is that you have less visibility, because unless you used conditionals in the code, like this example, Terraform workspace, you don't even know that you have workspaces, and even if you do Terraform workspace list and you see the workspaces, you don't know if they are in use or not. So you have less visibility, and it's very problematic in the long run to maintain it like that. And the last note that I want to mention here is that the usage of data remote state could be problematic when we use workspaces, because let's say you decided to use workspaces for cross resources like networking, then you need to call and know about these resources on other states as well. It's not like remote state because it's not in a backend. So it is confusing and it could be messy. So just have that in mind before you jump the gun and decide to go and work with workspaces. But there is one useful and classic workspace usage to be used like a side branch. So let's say I want to test my code. I want to see that it does whatever I'm telling it to do. I can create a new workspace, do my changes, see that everything works okay, and if so, then apply the changes on the default workspace, which is the production one. Okay, so to sum things up in terms of the structure in the Terraform codebase section, if you really think ahead, and if you really think about your use cases and how you should structure it is based on your use cases, then it will allow you to set up Terraform as a platform if it's something that you care, and if you want to grow and scaling is something that is important to you. And it will allow you to set up small states, which is, again, very, very important, because we want to prevent invalid dependencies from happening. If you don't think ahead when you structure a Terraform code base, then organizational changes might require you to restructure the code, and we don't want that. We want to be in control of our code. And also another bad thing is that to use workspaces for the wrong reasons could have potentially issues in the long run that you didn't foresee. The other thing, again, that if you, and I couldn't stress it enough, don't use a structure that will allow huge state files, because invalid dependencies will definitely occur. You'll change a tag, it will ask you to destroy a resource or something like that, and you don't want to touch the state file and try to fix things yourself. Treat Terraform state files as holy grail. Don't touch it, and just prepare in advance in order to make sure the state files are small. Another section is the Terraform execution. So also for scaling purposes, try to aim only for a Terraform remote execution. That way, it's good for scaling teams, because everyone can use it, and you'll have a handling of the state file lock. If you use Atlantis, for example, which is an open source tool for Terraform pull request automation. So this is one thing. And Atlantis also do it, once you open a PR, it does two things. It applies the code and also merge the code to the master or the main. So that way you have this handling, and it's all done remotely, so you don't need to deal with local credentials, local configurations, and you have audit. So Terraform remote execution is always a good thing. Try also to do apply with a plan file, because that way you know exactly what you're being applied. And this is something that Atlantis also does. And set up Terraform timeout that makes sense to you, because at some point in my career, I tried to create auto-scaling with spot instances, and the price wasn't right, and then I had to wait and wait and wait. So in order to not wait, just set up a Terraform timeout that is reasonable for you. A bad thing is to execute locally, because again, you need local credentials, configurations, and you have no audit, and it's very, very bad. But the ugly thing is to run locally and execute Control-C whenever you run Terraform apply. I don't know who did it here. I see some smiley faces. I did it when I just started out with Terraform, because I was impatient. I'm like, hey, what could go wrong? Everything, okay? The Terraform state file got messed up, and of course I didn't have backups that now I can tell you to do backups, because I didn't think about it then. So a lot of issues, and of course it was production. So just don't do it, okay? I don't know if they fixed this behavior or not, but trust me, I don't want to find out. So just don't do Control-C, rely on the timer that you will set up, and that's that. And finally, the section that I wanted to reach the entire, or that I did a build-up towards, practices enforcement. So basically, these are a set of checks that you can set up, or should set up, in order to basically check everything. Check the tags were added to the resources. Check infra cost, for example. If someone added in their PR infrastructure that costs more than $10,000, you want to alert someone. So any types of checks that you can think of, whether to test best practices in general or whether to align to your own best practices that you have in your company, can be set up through practices enforcement. This is done also in community models, which I'm going to show here. So in this, this is from Terraform AWS Autoscaling. So you can see they check if the contributor formatted the code with Terraform FMT, if they added documentation, and if the code is actually working, checked with TFLint. So these simple checks can easily remind developers to keep a high quality standard of PRs as much as possible, because if they are not passing, then the PR wouldn't get merged. So the good thing is to have pre-merge linters, formatters, and logical checks. You can do it with GitHub Actions. You can do it with CI pipeline checks, for example. You can create Slackbot drift reporter that will tell you once there's a drift between your actual environment and the code. Or you can do what we do in Wix with Atlantis, where we only apply with Atlantis, and that way, at the same time, the code gets applied and merged, so no drift here. The bad and the ugly is basically if you don't set up practices enforcement, then you could potentially face security issues, and a non-compliant configuration gets introduced to your code. And on the right, you can see some open source tools that can help you in your journey of introducing practices enforcement to your environment. This is the part where usually people take pictures, but I don't see, okay, some of you, okay. I really urge you to do that, okay? It's really, if you need to scale, practice enforcement is the way to go. Everyone can contribute to the code, and the code will still kept in a high quality because of these checks. So this is where I asked you this before. I'm going to ask you again, because this question I couldn't stress enough how important this question is in order to really think ahead and plan things through. And basically, if you plan ahead, you will enable others in their Terraform journey, and you will be able to set up guidelines and best practices of your own, like tagging resources or anything else. So this is what I want you to take out of this presentation. I don't know if this is big enough. You tell me, okay? But these are the main reasons, the main things. So think about your code-based structure to enable you to set up Terraform as a platform, so it will be helpful for scaling of your teams and your infrastructure as well, and structure the code base in a way that will have small state files, and implement practice enforcement to enable infrastructure teams and scaling, and basically you don't need to worry that things will get lost in the way because he's new or she's new and she doesn't know what to do. These checks could be the guardrails that you need in order to introduce more users to the environment. And basically, that's it. I think about Terraform in a way that, like any other tool, don't use it in a mindset of ad hoc. Plan ahead. And I want to quote another thing from Thyssen Uo's article. He said that programs evolve, right, and the code changes, and it is uncommon that you use Terraform the same way like everyone, because if it was the case, I wouldn't be standing here and talking about Terraform practices. Everyone not doing it the same way. We do it differently. So in order to make the most out of Terraform and to allow projects to get introduced to their environment, because what are projects? To move from current state to the next desired state. So in order to allow projects to get introduced, we need to think about structuring the code base and how we treat Terraform generally, and that way you will allow projects to evolve and get introduced. And by that, you will help your company grow and succeed and contribute to the company's success as well. And these are some references that I mentioned during my presentation. Labelings about tags, workspaces, useful documentation, Thyssen Uo's blog post, which is very good. I highly recommend to read it. And Superlinter is like it is a bundle of GitHub checks that out of the box you can introduce to the code base, and then you will have out of the box practice enforcement to get you started with this journey. So this is a good thing to implement, but again, you can implement whatever you want in order to check your for your use cases and scenarios. That's it. I really hope that you enjoyed the presentation. I don't have time for questions, I'm sorry, but you can catch me outside and I'll be happy to answer anything. Thank you.